Okay, so far we've talked about ionic bonds, and that is really how the gemstones are made. There's ionic metallic bonds inside there. Um, Today we're going to talk about the metallic bonds, metallic compounds. So the silvers, the golds, the things that we would, make the metal rings out of, or the metals that we make our pipes out of. Okay. Um, so how are ionic compounds labeled and named? We've already done that. So this would be how are metallic compounds created, and then being able to identify metallic compounds. Okay, so a metallic bond is formed when free electrons and metallic cations are near enough to cause a force of attraction between them. So basically, instead of having an anion and a cation, here we just have the positive ion, the cation, and then we have these free electrons, electrons that are like the valence electrons that are moving around. Okay, so those electrons kind of spread out between all of the cations. And so the result is a pure metal, like pure gold or pure silver or uh, pure aluminum. Okay. Um, Another way to look at this is to think about it as you have all these cations, all these metal ions. They kind of hang out next to each other. And then the electrons, their valence electrons, just get to kind of roam free in the area that they are, right? So they're not necessarily bonded, like strictly bonded to one cation. They're free to move around, but they have to stay within a specific range of the actual ions. Um, and so that kind of makes a sea of free electrons. So if you think of the electrons as water droplets, if you put them all together, you get this big sea of electrons that are floating around in the metal, which is why metals are really good conductors of electricity. Okay, so those metallic bonds are composed of repeating metallic structures with which give the compound specific properties. So if we're thinking about, let's say, gold is malleable. What that means is that you can hammer or press or do something to it to shape it without breaking or cracking it. And so, when you saw in the video, you saw him hitting the gold with the hammer. All that was doing was spreading it out, right? It wasn't breaking it. So basically, what's happening is you're hitting those free electrons and they're just kind of moving around a little bit. They're not necessarily breaking apart, they're not breaking off, they're just moving around in a different into different locations. Okay. Um, those metallic structures are ductile. And what that means is that they are able to deform without losing toughness. Okay. They're pliable, they're not brittle. So again, if I hit that metal, those electrons are just going to kind of move around a bit. They're going to, um, they're still there. And so we still have the gold or we still have the silver. It's not any more tough than anything else. You can still bend it and move it around and stuff. But it's not so tough that it's brittle where, like, if you bend it, it will break. If you think of like a piece of pencil lead, if you bend it, it's going to break. Where if you're using, say, copper or gold or silver in like a piece of wire and you bend it, it's not going to break. Okay. Again, it makes it very well conductive, right? Because of all those extra electrons that are kind of swarming around in that sea, electricity can get through very easily. So electricity can be conducted very easily in those types of metals. And then heat as well. electrons also carry heat from one atom to another, and so you're able to heat things up very well with them. The last is that they have high melting points and boiling points. So, if you've ever seen liquid gold, they have to heat it up in these huge furnaces, these big, huge blast furnaces. And so they have a very, very high melting point. Okay. And the how high depends on that force of attraction. So it depends on how many electrons there are and what type of element it is, and and like what type of structure that it creates. Okay, so now we've looked at metallic bonds. Can we now look at how the gemstone and the metal for the ring, how they go together and why they're put together in the way that they are?